Hello everyone, welcome to PM Networking. Hope you all are doing great. Guys, today in this video we are going to understand how to configure network like this from the IP addressing, because for network engineer IP schema is also very important, right? Like if you are designing a network, then you should have knowledge about the topology, like ring topology, star topology, which topology is going to be better for you. It depends on your design, right? So first we are going to understand the IP approach, and before that I will make you familiar with this topology, because first of all you have to understand the connectivity, like how these two sides are connected together. Okay, so in step 1, in first part, I am going to make you familiar with topology, guys. In part 2, I am going to make you understand IP addressing. In part 3, we are going to configure this topology. We'll understand the configuration, right? Because like you can see in my topology, this is, let's say, what, LAN 1, or you can say campus 1. This is LAN 2 or campus 2. Both are at different location, right? Maybe in different city, maybe in different country, and both are connected through what? Internet, guys. This is what? Internet. That means router 1 is my edge router and router 2 is my edge router. Router 1 is edge router for LAN 1, router 2 is edge router for LAN 2, or for campus 1 for campus 2, right? LAN 1 is connected to ISP 1, different ISP, maybe Airtel, or R2 means LAN 2 edge router is connected with ISP 2. It can be, let's say, Geo, right? This network is in, let's say, Delhi, and this one is in Mumbai or Bangalore, Ahmedabad, somewhere. And in future, maybe you are going to add more branches, right, in upcoming videos. But in this video, try to understand the basic configuration, right? So on router number 1, guys, if these user want to access internet, then you have to configure NAT also, translation, right? In this network, somewhere you need to configure public IP address, somewhere you need to configure private IP addresses, right? So you have to choose both network, then you have to perform the subnetting. Okay, so you can see in LAN 1 I have one DHCP server as well, right? And this DHCP server is centralized, means all end user in LAN 1 should be able to get IP address from DHCP server. All user in LAN 2 should be also able to get IP address from DHCP server, which is located at different location in LAN 1, because I am not going to put one separate DHCP server in at each location, because right now I have only 2 branch offices, but in future maybe I am going to launch 10 number of branches or 100 number of branches. After 5 years I am going to launch 100 number of branches. After 10 years I will have 500 number of branches. So I need to put 500 DHCP server, right? If you are going to put one server at every location, 500. So that's why DHCP server will be also centralized, guys, in my network. So DHCP server is there in LAN 1, and all branch or remote users will get IP address from this DHCP server only. Then if this user want to access internet, you have to configure NAT. So we will configure NAT also. After that, to make communication possible between 2 private network, because this is my private LAN 1 and LAN 2. If you want to make communication possible between 2 location, between 2 point over internet, what option you have? You need to configure tunnel over here. So we are going to implement tunnel as well, and you have to secure it. Definitely you don't have firewall, but on router as well, guys, there are some security features. So if you want to learn security feature, you can check security playlist. Fine. Maybe here we are not going to apply security, but we will make reachability between LAN 1 and LAN 2. There should be reachability. So in part 1, we understood the topology. In part 2, we are going to understand IP address approach. In part 3, we are going to configure this topology. And guys, then in part 4, we are going to verify the configuration. And in part 6, we will troubleshoot it if there is some problem. If there will be some problem, if there will be no connectivity between LAN 1 or LAN 2, we will troubleshoot it. If these users are not able to access, to configure IP address or to get IP address from DHCP server, we are going to troubleshoot it. Okay, so let's begin. Now hope topology is clear. In my topology there are two private network, both are connected through internet, right? DHCP server is centralized. Requirement is there should be end-to-end reachability. Network should be reliable, scalable. Okay, so now guys, between ISP1 and ISP2, doesn't matter what network they are using, it is not your concern. Definitely this is public IP address, but this is not your concern, right? What IP address they are using. So that's why I have already configured IP address on this interface and this interface, means on ISP1 and ISP2, because this is concern of ISP. How to configure it, how to manage it, it's not your task. You need to configure your R1 router number 1. So here you need one IP address. You have to purchase the public IP address for this interface. Here also you have to purchase the public IP address for this interface, right? So how many public IP address is required, guys? Two public IP addresses required, one for R1, one for R2, means one subnet over here and one subnet over here. Okay, so as you can see here, public IP range, what public IP addresses I am going to use. Okay, so my first network, my main network is 1.1.1.0/24. This is my main network for public IP addresses, right? Then guys, I have subnetted it into two parts because I need two subnet, one for LAN 1, one for LAN 2, right? And here between router 1 and ISP1, how many IP addresses are required, guys? Only two, one over here, one over here. So I'm going to use /30, right, to reduce the wastage. Now I have divided into two parts, like into several parts, not only two parts. 1.1.1.0/30, so that I will get only two IP address, right? So next network is going to be what? 1.1.1.4/30. Next network is going to be 1.1.1.8/30. So I'm going to use this network, guys. First network for LAN 1, second network for LAN 2. Fine. Then IP address, see, R1 and ISP1, what network I am using? 1.1.1.0/30. Okay, this one for this one. For between router 2 and ISP2, I'm using this network, and maybe this is reserved for upcoming branch. Okay, and here you can see the IP configuration. On router number 1, you need to configure what IP? 1.1. Over here subnet is 1.1.1.0/30. Here IP address is .1. Definitely here IP address will be what? .2. Here IP address is what? .5. Here IP address is what? .6. Like this. Network ID over here 1.1.1.4/30. So first IP address is 5, second IP address is 6. Okay, then guys, private IP addresses. So you can see my main network is private IP range. This is public IP range, this is private IP range. Private IP range 10.1.1.0/24. This is my main subnet. Here I have, for now I have only two campus, so I have divided it into two parts, right? But let's say here I need only 50 IP addresses, then I will again perform subnetting. But now I am equaling this network into two parts, because total number of user over here is 254. So I am dividing it into two parts. Okay, so first network 10.1.1.0/25, second network 10.1.1.128/25. Okay, for LAN 2. This is for LAN 1, this is for LAN 2. Okay, so we need to configure DHCP in such a way so that DHCP server should provide IP addresses to these users from this network, from 10.1.1.0/25, and to these user from this network 10.1.1.0/28 network. And DHCP server is in different network. Even you can connect DHCP server here as well, but what I am assuming that in LAN 1 or in campus 1 I have two building, right? This one is one building, and this is, let's say, a small server room where servers are placed. So that's why I have directly connected I have directly connect the server room to router number 1. Even I have choice to connect it with switch as well to place it in same network. Okay, but in my scenario DHCP server is in separate network. Then guys, last IP is gateway in both. So here network is 10.1.1.0/24. Last IP address is 25. So last IP address is going to be what? 10.1.1.126, because say 27 is broadcast, 28 is next network. So on this interface you are going to configure this IP address. This should be very clear to you, right? Because with the help of this information you need to configure IP addresses on each device, right? Because here it's clearly mentioned everything. Second network is going to be what, guys? Here 10.1.1.128. So last IP address is going to be what? 10.1.1.255 will be broadcast address, that means 254. You need to configure this IP address on this interface. Getting my point? And it's your concern how you are going to make reachability between R2 to DHCP server, or you can say between client to DHCP server. Because if this client want to get IP address from DHCP server which is located at different location, there should be reachability. This device need to communicate with DHCP server, so there should be reachability. Okay, so now how to make reachability? Let's move to the configuration part. Hope IP addressing is clear. So first of all, let me assign the IP addresses on device, guys. And here what subnet I am going to use? Let's say here I am going to use this subnet 192.168.10.0/24. This is my subnet. Again here last IP address will be the gateway for this server. Now let me check I have access or not. Yes. First of all, if you want to check ISP router configuration, what I can do, I can show you the ISP router configuration, guys, because I have already configured the IP addresses. So IP interface brief exclude unassigned. Okay, so this is only configuration of ISP router. If even you can check, so run. I have not configured anything on ISP router. See that these are what default configuration, right, guys? Default configuration. Only I have assigned IP address on this interface and IP address on this interface. That's it. Apart from it, all are default. Fine. On ISP2 also. So IP interface brief exclude unassigned. So here you can see IP only. Fine. Now let's move to router number 1, guys. On router number 1 I am going to configure IP here, because on router 1 only default configuration are there, right? There is nothing. So go to interface F0/0. So what IP address here you are going to define? No set and then IP address 1.1.1.1. 2 is running on ISP side. Here also you can see 1.1. That means 2 is running ISP side, .2 is on ISP side. Then subnet mask 255.255.255.252/30. Now let me verify the connectivity. Do ping 1.1.1.2. Am I able to ping ISP? Yes, I am able to ping ISP. You can see success rate is 80%, and this time success rate is going to be 100%. Fine. Now let me assign IP on LAN interface. Interface F0/1, say no set, and IP at interface F0/1. So run. Interface 0/1 is not there, na? 1/0 is there only, but here it's showing 0/1. It is, this one is 1/0, not 0/1. Okay, fine. Now let me do config t interface F1/0, say no set, and what IP address here I am going to assign? 10.1.1.126, last IP address of first subnet mask 128/25. Then guys, on the interface which is connected with DHCP server means F1/1, say no cert, and IP address 192.168.10.254, last IP address 255.255.255.0. Done. Let me verify the IP configurations brief. Yes, all interfaces are up, their line protocols are also up. So R1 configuration is done, means IP configuration on R1 is done. Let me do IP configuration on R2 guys. Interface F0/0 no set IP address 1.1.1.5 255.255.255.252 and do ping. Let me verify the connectivity between R2 and ISP 1.1.1.6, last IP address, second IP address of second subnet. Yes, ISP is reachable from R2 as well. Then interface F1/0 say no set and IP address 10.1.1.254. 5 is the broadcast address of second subnet 128. Let me verify the IP. Exclude, unassigned. Fine, IP configuration is fine guys. Now I am going to configure the DHCP server. Let me enable the DHCP service here. So config T IP DHCP. First of all, I am going to exclude the IP addresses which I have already assigned. Like on router 1 LAN interface, I have assigned what guys? 10.1.1.250, sorry, 126. Last IP address, right? So I have excluded this IP address, and one more IP address I need to exclude, that is 10.1.1.254, which is running on router 2 LAN interface. Then I need to create pool. So IP DHCP pool name is, let's say, LAN 1. For LAN 1 I am going to define what network 10.1.1.0 submit mask 255.255.255.128, right guys. Then default gateway, so here I think command is router or default, yes, default router 10.1.1.126 is going to be default gateway IP address for LAN 1, and then DNS server IP address, let's say 8.8.8.8. If you want to provide TFTP IP address, you can configure option 50/150, option 50/150, then IP, and then you can assign the IP address of your TFTP server. Okay, but I'm not going to define TFTP server IP address here. Next configuration is we need to create one more pool over here for LAN 2. So IP DHCP pool and LAN, let's say 2. Here network is going to be what? 10.1.1.128.255.255.255.128 network ID of second network. Then guys, default router is going to be 10.1.1.254, right, and DNS server IP address 8.8.8. So now DHCP configuration is done. So run, you can verify the command. So run section DHCP. If you are missing anything, no. So as I am using this device as a DHCP server, I am going to disable routing. So say no IP routing over here, right? So I am going to assign one IP address to this DHCP server as well, guys. So do one thing, interface F0/0 no cert and IP address, because here IP address is required, and 192.168. let's say 10.1 255.255.255.0, who is the default gateway of this DHCP server. IP default, not here, in global config mode, IP default gateway. Default gateway IP address 192.168.10.254, right? For DHCP server, for this DHCP server, this interface IP address is going to be default gateway. Here we have configured this IP address, correct? So now we have set up the DHCP server in my network, right? Now, can I get IP address in LAN 1 from DHCP server, guys? If I will try to assign IP address on PC1, will PC1 get IP address? So let me try. Let me go take you to PC1 and say IP DHCP. So it is trying to perform DORA process. It is sending discover message, guys. Yes, PC1 is sending discover message. But why this PC is not getting IP address from DHCP server? Here we have already assigned the IP address on this interface. On this interface, IP address is already assigned, configured, right? And both interfaces are directly connected. So both network are in the routing table of router 1. Still, these PC are not getting IP address. Why? Because discover message is broadcast. So PC1 is going to broadcast the discover message and router never process the broadcast. Let's say if router 1 will receive the broadcast address, broadcast packet, right, on this interface on F1/0, what router 1 will do? It will check destination IP. Destination IP is 255.255.255, and helper address is not configured over here, right? Router 1 cannot forward broadcast message from one interface to another interface, right? Until you will not configure the IP helper address, these user will not get IP, right? Here you have to configure that IP helper address. After that, what router 1 will do? It will convert your broadcast packet into unicast packet and then forward to DHCP server. When DHCP server will generate reply, it will generate reply to whom? To router. Because in the router in your discover message, router have changed the destination address. Earlier it was on broadcast. Now you have till to router number 1. Brother, my DHCP server IP address is 192.168.10.1. With the helper address, what we are doing? We are telling to router, brother, this is IP address of my DHCP server. Whenever you will receive a discover message, please forward to this IP address. So router 1 is going to change your destination from broadcast to unicast, then it will forward to DHCP server. When DHCP server is going to reply him, it will reply to router, and then router will reply to your PC. So on R1, let me configure one feature, that is IP helper address, guys, and then let me try again. So where is router 1? This is router 2. Let me access router 1 again. Config T interface F1/0. Say IP helper address. What is the IP address of DHCP server? 192.168.10.1. Right. So now this router 1 is going to convert your broadcast to unicast, and then it will forward to DHCP server. Earlier your router R1 was dropping the packet because it was broadcast packet, and DHCP service means DHCP helper address was not configured there on the interface. But now I have configured the helper address. Let me try to assign IP on PC1 from DHCP server. Again, say IP DHCP DORA D1 discover is failed, and now you can see it's working. DORA process is done. Now this PC have got one IP address, that is 10.1.1.1/25. Correct IP address, correct subnet mask, correct default gateway IP address 10.1.1.126. The first thing is I am going to check my default gateway is reachable or not, because it is very important. So let me do one thing, 10.1.1.126. Let me check. Yes, you can see my default gateway is reachable. Correct, guys? So PC1 is able to get IP address from DHCP server. Okay, and it have got what IP address, guys? 10.1.1.1. Okay, now let me take you to PC2 and say IP DHCP PC2 have also got the IP address 10.1.1.2/25, gateway 10.1.1.126. Good. PC3 IP DHCP. PC3 have also got the IP address. But guys, can PC4 get IP address from DHCP server? No. First problem, IP DHCP. First problem, router 2 is going to drop the discover packet. Why? Because router 2 is not going to process broadcast packet. So first of all, you need to enable IP helper address on this interface. So let me take you to R2, and let me configure IP helper address. Interface F1/0 IP helper address. What is the IP address of DHCP server? 192.168.10.1. Right? But now, can PC4 get IP address from DHCP server? No. What is problem this time? See, this time what is problem? When this PC will generate a discover message, source IP 0.0.0.0, destination IP 255.255.255.255, right? PC will forward it to router 2. Router 2 is going to check what? First of all, router 2 will receive this packet on 0/1 interface, right? And guys, IP helper address is enabled over here, already configured. So this router is going to change the destination. Source is going to be same 0.0.0.0. Destination helper IP address 192.168.10.1. Now this router R2 need to forward this packet to whom? To 192.168.10.1. But is route available for this network in routing table? So router 2 is going to check what? Routing table. Why? Because to forward this packet to 192.168.10.1, router 2 need what? Exit interface. From which interface I will exit this packet? I will out this packet. Okay. So they need exit interface, and to find the exit interface, router 2 is going to check their routing table. So IP route. But guys, you can see in the routing table 192.168.10.0 network not available, is not available. Only 10 network is there and 1.1.1.4/30 is there. Okay. So DHCP server is not reachable from your edge router. Now how to make reachability? See guys, to make communication possible between two private network over internet is not possible. The technology which we are using to make it possible is known as VPN, virtual private network. By default, two private network cannot communicate through internet. So the technology which we are using to make it possible is known as what? VPN, virtual private network. What we will do? See guys, this is what? Private network. Here we are running what? IP addresses. Private IP addresses. Here also we are running what? IP address? Private IP addresses. Here we are running what? IP address? Public. Here we are running what? IP addresses? What type of IP address? Public. Here what? Public. So private and public cannot communicate with each other. Private and public cannot communicate with each other. The technology which we are using to make it possible is known as what? NAT, network address translation. With the help of NAT, we can make communication possible between private to public. And with the help of VPN, we can make communication possible between two private network over public network. Right? So what we will do through VPN, we can create one tunnel between R1 and R2. Then guys, we will assign one IP address on this point and one IP address on this point. This public IP address and this public IP address are reachable with each other. So we are going to use these two public IP address as these two are reachable to create this tunnel. Through this tunnel, I want to forward any private packet, right? Any type of packet I want to forward through this tunnel. So I can. Why? Because this IP address on this interface and IP address on this interface both are reachable. So with my actual data, before forwarding through this tunnel, I am going to add one extra header where source IP address I am going to put this interface public IP address. This interface public IP address, that is 1.1.1.1, and destination IP address is 2.2.2. Sorry, not 2.2.1.1.1.5. IP address of remote public IP address, you can say, right? Source public IP address, destination public IP address. In the packet, guys, if source is 1.1.1 and destination is 1.1.1.5, then can ISP forward this packet? Yes, because these are public IP. ISP have route for public, right? But you know how ISP knows LAN 1 and LAN 2? ISP 1 and ISP 2, both ISP knows both network LAN 1 and LAN 2 with their public IP address. So the IP address which is running over here 1.1.1.1, 1.1.1.5, these two IP address, ISP will know LAN 1 with the help of this IP, ISP will know LAN 2 with the help of this IP. That's it, right? So private IP addresses are not routable on internet. So we are going to do what? We are going to create one tunnel over here, and through this tunnel we will forward private packet. So let me do one thing. Let me configure the tunnel, guys. On router number 1, see, interface tunnel 1. This is virtual interface. This is virtual interface tunnel 1. Then I am going to define one IP address on tunnel. So let's suppose on the tunnel I am going to use this network 1.1.1.8/24, this one. So let me assign the IP again. IP address 1.1.1.9 255.255.255.252, not 24, 30/30. Next network. Okay, on R2 config T interface tunnel 1 IP address 10.1.1.9 10, sorry, not 10, 1. .255.255.252. Now can these two IP addresses communicate with each other, guys? Here we have defined IP what? 1.1.1.9/30. Here we have defined 1.1.1.10/30. Let me write over here. Here IP address is on this tunnel 1.1.1.9/30, and over here 192.160, sorry, 1.1.1.10/30. This is my tunnel. Right. So can 1.1.1.9 ping to 1.1.1.10? Will ping work, guys? No, ping will not work. Why ping will not work? See, first of all, let me verify this also. From router number 1, I'm going to say do ping 1.1.1.10. See, ping is not working. Why ping is not working? So IP interface brief. This network is running on tunnel interface. Exclude unassign. Here tunnel interface is not showing brief. So you can see your tunnel interface. Tunnel interface is what? Down. Line protocol of tunnel interface is, guys, down. Why line protocol is down? Why line protocol is down? Because we have not defined the source IP address and destination IP address. As I told you, my public IP address is going to be source, and remote public IP address is going to be what? Destination for this tunnel. So I'm going to tell to router number 1, brother, whenever you will forward traffic from the tunnel interface, please add one extra header where source is going to be this one, destination is going to be this one. So let me do, go to config T say interface tunnel again 1 and tunnel source. My public IP address tunnel destination 1.1.1.6. Is these two IP addresses are reachable with each other? Yes. Do ping 1.1.1.1.6. Not working. So this IP address is in different network, this IP address is in different network. The network ID of this IP address is 1.1.1.4, and guys, this network is not available in routing table. So do so IP route. You can see 10. So on edge router, what we want, that edge router should forward all traffic towards ISP. So we will configure one default route over here. So let me take you to R1, guys. On R1, say IP route 0.0.0 0.0.0, and next hop IP address 1.1.1.2. That's it. Now router 1 can forward packet to ISP 1, to ISP router, you can say, right? If source is 1.1.1.1, destination is 1.1.1.6, what router 1 will do? It will look up their routing table. In their routing table, there is no any route. See network ID of this IP address, this network 1.1.1.4, network ID of this network 1.1.1.0, right? So this route is not available in the routing table. Do so IP route not available, but this time router will not drop the packet because default route is configured, right? See, gateway of last resort is 1.1.1.2, means next hop IP address. If router will not found any entry in the routing table, then it is going to forward that traffic to this IP address, which is ISP1, this interface IP address, right? Yes, now you can see. So IP interface brief tunnel is now up. Tunnel interface is now up. Here tunnel interface not showing, but you can see over here tunnel is up. Now your tunnel is up. So run interface tunnel 1. So you can see the tunnel interface configuration. I have created one tunnel interface where I have defined the IP address and subnet mask. Then I have defined the source tunnel IP address and destination tunnel IP address. That's it. Okay. On router number 2 is tunnel up. So IP interface brief. No, tunnel is down. Why? So run interface tunnel 1. We have not defined the tunnel source and tunnel destination. Go to tunnel interface and then say tunnel source 1.1.5, destination tunnel destination 1.1.1, and here on router number 1 tunnel destination should be what, 5, no guys? Let me correct it. Interface tunnel 1, tunnel destination 6. Say no to this command and then say tunnel destination 1.1.5. Now it's correct, right? On router number 2, I have defined the tunnel source, tunnel destination, so IP interface brief. Now you can see tunnel interface up. Now this tunnel is up. Source IP, when router will forward traffic from the tunnel, then source is going to be what, 1.1.1.1, destination is going to be what, 1.1.1.5 every time for all the traffic of this LAN. When PC will ping, when router will ping, when router 3 will ping, doesn't matter, right? whatever traffic router 1 will forward through this tunnel, source IP and destination IP address is going to be always this one, because of tunnel interface configuration. See, tunnel source, this is R2, so run interface tunnel 1, tunnel source, tunnel destination, whatever packet will be forwarded through this tunnel, always source IP address is this one, destination IP will be this one, and both are public, right? That means routable on the internet. And guys, on this tunnel interface, what is the IP address? On this tunnel IP address 1.1.1.9/30, here .10/30. Let me check the connectivity between this tunnel point to this tunnel point, right? So from router number 1, guys, I'm going to verify the connectivity. To do ping 1.1.10 and source 1.1.1.9. Yes, there is reachability. And now if there is reachability, guys, we can configure any routing protocol on this tunnel interface to exchange route, right? So like here, if you will configure OSPF routing protocol, so OSPF neighborship will come up on tunnel interface. So now if we have tunnel here between router 1 and router 2, can these PC, means PC4, PC5 and this server, pmnet.com server, are able to get IP from DHCP server? Let me check. Let me take you to PC4 and say now again IP DHCP. Still no. So this PC is not able to get IP. Now what is the issue? Let me do one thing. From router 2, I am going to check connectivity, means connectivity between router 2 to DHCP server. So go to router 2. First of all, ping my tunnel IP address. Source. Yes, fine. Ping 192.168.10.254. It will not work, ping will not work, but because if you are pinging directly like this, then router 2 will forward traffic from fast Ethernet 0/0, right? Because guys, router 2 is going to check what? Routing table. Router 2 is going to check routing table, and for 192.168 we don't have any route, right? So router will use what? Default gateway, default route. It will forward traffic to this IP address directly. Problem is router 2 don't have this route, this network information or this network information, right? So to exchange the route, either we can configure routing protocol on the tunnel, right? Let's say I've configured the OSPF. Now we have OSPF neighborship. Then I'm going to advertise this network in OSPF. Router 1 will forward to router 2 through tunnel interface. Router 2 will forward this network through update message to router number 1 through tunnel interface. So either we can configure any routing protocol or a static route. So see problem, first ping 192.168.10.1 and source 10.1.1.129, my LAN interface IP address, not 129, 254. This is LAN 2. Say ping is not working. The reason is this router 2 don't have route for this network. Router 2 don't have route for this network. So it is going to check their routing table. So IP route. In their routing table, route is not there, right? So it is going to use what? Default route. That means it will forward traffic to 1.1.1.6. It is going to forward traffic to ISP router without adding extra header, right? Public source, public destination with private packet. Only if exit interface is tunnel interface. So either I can configure one route here on router number 2. I can say IP route, means router please install 192.168.10.1 with subnet mask 255.255.255.0 in their routing table with next hop IP address what? 10 dot means tunnel interface IP address 9 10.0 this network. Okay, right, because from router number 2 I am able to ping this tunnel IP address. There is reachability through tunnel between R1 and R2, right? So now if you will check the routing table, so IP route, you can see guys there is one static route network 192.168.10.0/24 reachable via 1.1.1.9 and 1.1.1.9 is reachable via which interface? 1.1.1.9 means network ID 1.1.1.8. 1.1.1.8 is directly connected on tunnel 1 interface. That means exit interface is tunnel interface. If exit interface is tunnel interface, please add extra header, right? So guys, in inner header source IP address will be what? Let's say this interface is pinging to this interface. Source IP address will be, source IP address is going to be what? 10.1.1.254. Destination IP address is going to be 10.1.1.126. And it will add one new header because exit interface is tunnel interface. And in that header, source IP address will be what? 1.1.1. My public IP address 5. Destination IP address 1.1.1.1. Right? And then it will forward to ISP1. So because of this time ping should work. Ping 192.168 dot, or let's say what? Yes, 192.168.10.1 with source 10.1.4, and this time ping should work. But if ping is not working, then what problem guys? That means on router number 1 also don't have this network, right? So on router number 1 also we need to configure one route, like go to R1 and say IP route which network? 10.1.1.128 subnet mask 255.255.255.128. Next up IP address 1.1.1.10, right? Now from router number 2 if I will ping, this ping will work. You can see ping is working. That means my tunnel is working fine through tunnel. So as now there is reachability, means router number 2 is able to ping DHCP server 10.1 with source working, right? So now I am expecting that PC4 can get IP address from DHCP server, and let me try. Go to PC4 and say IP DHCP D Ora. You can see PC4 got the IP address, and see guys, correct subnet 10.1.1.129 first IP address of second network, default gateway, correct, right? Then PC5, this server PC5 IP DHCP fine, server IP DHCP. Now in real time you have to configure multiple DHCP services, multiple DHCP pool, because now we are going to divide this network into a smaller network. Like we are going to implement VLAN. For one VLAN we are going to use different subnet, for another VLAN we are going to use different subnet. Like in network 1, LAN 1, my main network is 10.1.1.0/25. So I'm going to do subnetting over here on this network. Maybe I will divide it into 2 parts like this, right, for each VLAN. Here you can see server has also got the IP address third IP address from second network, correct default gateway. First of all, I will verify the connectivity to my default gateway 10.1.1.254. Yes, I am able to ping my default gateway. Now question is, can these user communicate with these user? Let me check. Let me try. Go to PC1. Where is PC1? Here is PC1 and say ping. What is the IP address of PC4? 10.1.1. PC4 IP address 129. 129. No, ping is not working. But request, I'm getting request timeout error. What is the problem, guys? Problem is very simple. See on router number 1. When I am pinging this IP address, router number 1 will receive it and it will check, it will compare the destination with their routing table. It will check routing table, so IP route. In the routing table, is route available? This route is available and reachable via tunnel interface. So it will add extra header and it will then forward to router number 2. Router 2 will receive it and it will forward to PC. When PC will generate reply, source IP is going to be what? Means destination network is going to be what? 10.1.1.0, but router 2 don't have root. 10.1.1.0 is not there, you can see. So here we need to add this network also, this LAN 1 also on router number 2 routing table, or we can configure dynamic routing protocol. So very quickly I'm going to configure any dynamic routing protocol, guys. Here let me protocol here, let's say router OSPF process 1 and router ID 1.1.1.1. then guys go to interface tunnel 1 and say IP OSPF 1, let's say area 0. Need to do same thing on router number 2 also. So router OSPF 1, say router ID 2.2.2.2, exit interface tunnel 1 and IP OSPF 1 area 0. Now I am expecting OSPF neighborship between router 1 and router 2. Yes, you can see we have OSPF neighborship, right? Do so IP OSPF neighbor. Okay, stateful. You can change the network type as well. Now to exchange route, we need to enable OSPF on LAN interfaces. So go to interface F1/0, say IP OSPF 1 area 0, and then guys on router number 1 interface range F1/1 as well as F1/0. On both interface I am going to enable OSPF area 0. Right now you can see, so IP route OSPF. Here we have a static route, do so run section IP route. I am going to remove a static route now, say no to this, and on router number 2 also I am going to remove a static route, do so run section IP route and say no to this route. Okay, and on router number 2, so IP route OSPF, you can see router 2 is learning both LAN, right? This network also and this network, LAN 1 main campus and server room, right, through OSPF. And now these user can communicate with each other. So you can check from PC1. Now PC1 is able to ping PC4 or not. So go to PC1, PC4 IP address 10.1.1.129. Here is PC1 and say ping 10.1.1.129. This time ping should work, and you can see guys ping is working. So now we have connectivity. Now here in this topology you need to implement what? Now you need to implement security features, right? You need to configure the ACL, like guys on this interface, through this interface I want to receive traffic of this and this only. Means On this interface, in odd direction, I want to allow, let's say, only traffic of 10.1.1.128 network and 192.168.10.0 network. So what you need to do here, you need to configure the ACL in the same way on ISP. This interface, I only want to receive traffic where source is going to be what? 1.1.1.1, because every time source will be this one, right? Even in the NAT. So here you have to block all the traffic except this IP address. Like this you can implement the ACL, and then we have many more features, guys. But this video is now very lengthy, so we'll discuss those things in another video, guys. If you have learned something from this video, please hit on like button. If you have not subscribed my channel, guys, please subscribe this channel. We will meet soon in next video. Till then, stay safe. Bye bye. Again, any question, put it in comment section. If you have learned something, please like the video and just type yes in the comment section. Yes, I will get yes, you have learned something. So it will motivate me to make another video, right? Your feedback is rather very important. So just let me know how was the configuration. If it was fine, useful, knowledgeable, definitely I will make part 2 of this video where I will implement the security and NAT. Okay, bye bye guys, that's all for today for this.